MQTT, or Message Queue Telemetry Transport, is a lightweight, publish-subscribe protocol under the ISO standard, mainly over TCP. It's ideal for low-bandwidth environments like IoT due to minimal overhead. In industry, MQTT collects and processes data, using cloud resources for analysis, unlocking value. It forms an ecosystem across cloud platforms and IoT devices. The protocol uses a client-server model with a broker. It has characteristics of being open, simple, lightweight, and easy to implement. MQTT communication overhead is very low, with a fixed length header of only 2 bytes, making it very suitable for low bandwidth and constrained hardware and network conditions. It can be easily embedded into various types of applications and devices, especially in embedded areas like the Internet of Things, IoT, smart homes, smart sensors, and wearable devices. Here is a typical application scenario of MQTT in the industrial field. In this scenario, there is a large amount of dispersed industrial field data and information that needs to be collected, processed, and aggregated to the cloud, or IT end. By leveraging resources from the cloud, or IT end, such as storage, computing resources, big data, and artificial intelligence, we can mine the huge commercial value hidden in the data. Next, let's delve deeper into the characteristics of the MQTT protocol. On the right is a simple model of the MQTT protocol. MQTT is based on a client-server model of message publishing and subscribing. Unlike most Ethernet protocols, the publisher does not send messages directly to the subscriber. There is an intermediary message broker, also known as the broker. The broker's job is to filter all incoming messages from publishers and correctly distribute them to subscribers. It supports a massive number of client devices, with each client having a unique client ID. For the broker, communication is one-to-many. Now, let's look at the entire process of message publishing and subscribing through an animation. First, the data producer publishes data to a specified topic on the broker. The server distributes the specified topic to interested clients based on subscriber information. Clients can both publish and subscribe to data. If there is an unstable network situation, MQTT has message quality and delivery assurance to cope with poor network environments. MQTT can achieve reliable and secure message transmission and can operate over the TLS, Transport Layer Security, protocol, which provides data security and integrity assurance for communication. Ports 88883 and 1883 are registered by the Internet Assigned Numbers Authority, IANA, specifically for MQTT, TLS, and non-TLS communication. A topic refers to the keyword used by the MQTT broker for message filtering. Topics are hierarchically organized, similar to files or folder directories, essentially being a string of characters organized by slashes. For example, sports, talk, basketball, NBA. Subscribers can easily understand the content of the data through this topic. If a subscriber has broad interests and wants to subscribe to messages not only about basketball, but also about football, table tennis, etc., they will end up with a long subscription list, which can be cumbersome to manage. In this case, wildcards are needed. For instance, if a client subscribes to Sports Talk, the broker will distribute all subtopics under Sports Talk to that subscriber. Similarly, if a client subscribes to Sports Talk NBA, the broker will distribute data from that specific topic, but will not distribute messages from the next sublevel. Wildcards can match a single level, but their more commonly used function is to handle system messages. Next, let's briefly introduce the message quality levels in the MQTT protocol. They are divided into 3 levels, 0, 1, and 2. The higher the number, the greater the communication overhead, and the higher the communication quality. Level 0, QS0, relies entirely on the underlying TCP for reliability, has minimal overhead, and is widely used for data sources that continuously report data. However, if there is a network disconnection, messages may be lost. Level 1, QS1, ensures that messages are delivered. Even if the network is unstable, but there may be duplicate messages, which need to be handled in the program. Level 2, QS2, is the highest level of message quality. It guarantees message delivery without duplicates, but the communication overhead is significant, and most cloud service providers do not support it. There are two ways to aggregate industrial site data to the MQTT broker. The first method is to connect the data to the MQTT broker through gateways or other conversion devices. This method can aggregate various types of new and old devices on site without requiring each device to support MQTT or modifying the programs of the on-site measuring devices. Adding gateway devices also increases edge computing power, making it easier for data reconstruction, pre-processing, and so on. When the broker is deployed in the cloud, not all devices need to be connected to the internet. The second method is for on-site data personnel to connect directly to the MQTT broker. This method has a simple network structure, and as MQTT becomes more popular, more devices are equipped with MQTT communication capabilities.